Okay, so hopefully you answered this question and you said, oh, well, what I would need here is a common denominator. So I would go, my common denominator would be x plus 2, x plus 4. So I'd have to multiply the top of this one by x plus 4 minus, and this one I'm going to multiply top and bottom by x plus 2. So I'll have x plus 2 up there, x plus 2, x plus 4. All right, and then my numerator is going to be 5x plus 20 minus 4x minus 8. And my denominator, well, let's say I FOIL out the denominator. I'll get x squared plus 6x plus 8. Combine like terms, you get x plus 12 over x squared plus 6x plus 8. Hey, that looks familiar. That is this integrand. All right, so what that tells us is, since this difference gives us this more complicated fraction, it means I can take this fraction and decompose it into parts and make partial fractions that are each simpler. And in fact, having linear denominators, they can be integrated using the log function. All right, so that goes like this. So I'm going to say that my integral that I had of x plus 12 over x squared plus 6x plus 8 dx, I'm now going to write as the integral of 5 over x plus 2 minus 4 over x plus 4 dx. Now, what I'll do is go ahead and split this up into two separate integrals. You can do that, by the way. We've done before where I combine two integrals into a single integral as long as the limits are the same or there are no limits. So then I could split this up, and I'm in fact going to write 5 times the integral of 1 over x plus 2 dx minus 4 times the integral of 1 over x plus 4 dx. All right, so basically what I did is get 1 in the numerator, and my denominator is linear. Now I can just say, you're really using a u substitution, u equals x plus 2, but since the u substitution is now linear, unlike up here where the u substitution was not linear, so I couldn't do it, here the u substitution is linear, so I can do the old 1 over g prime trick. So I can say this is equal to 5 times the ln of absolute value of x plus 2, because the antiderivative of 1 over x is ln of absolute value of x. Keep the inside function the same, multiply times 1 over the derivative of the inside function, but the derivative of the inside function is 1, so I don't have that. All right, and then I have minus, this one's going to be 4, same thing, ln absolute value of x plus 4. Now, once I've done all my antiderivatives, I put my plus c. All right, now you're going to be able to, once you hit the hang of this, you're going to look at this and you're going to right away say, oh, this is 5 ln of absolute value of x plus 2 minus 4 ln of absolute value of x plus 4. And the only thing you'll keep in mind is if, for example, this were 3x plus 4, then I would put times 1/3 there for the 1 over g prime. And that's basically the method of the partial decomposition of fractions. But here's the trick. How did I know that that was going to come out to be the integral that I wanted? I just wrote that integral. How did I know that these two things were going to give me that integral? I think he cheated somehow. Well, I'll show you how you can find out, regardless of what that numerator denominator is. Of course, there's within some limits. All right, integral of x plus 12 over x squared plus 6x plus 8 dx. I'm just copying over what we're looking at. All right, so what we're going to do is say, how do I break down a rational expression into its partial fractions? And the answer is that, so you probably notice that the key is that the denominator can be factored, and the factors are here. So the first thing you're going to do is factor the denominator. So this is equal to x plus 12 over x plus 2, x plus 4. So you have to be pretty good at factoring, of course, to do anything in math. All right? And then here's what I do. So once I know what the factors of the denominator are, well, I'm going to say, well, these two had to be a common denominator for something. Something over x plus 2 plus something over x plus 4. And all I have to do is find out what the a and the b are. And that's surprisingly easy to do because I take this rational equation. Fortunately, you paid good attention in your Algebra 2 and your honors pre-calculus, so you could multiply both sides of an equation like this by x plus 2, x plus 4, and you would end up with x plus 12. So you're multiplying by the least common multiple of all the fractions, equals, so I'm going to have a times x plus 4 plus b times x plus 2. If it's not obvious to you where that came from, see me in Flex and I'll show you the details, but basically you're multiplying by x plus 2, x plus 4. All right, so now what we do is we distribute out the a and the b. So we got x plus 12 equals ax plus 4a. Everything from here on is algebra. Plus bx plus 2b. Or is it? Is that 2b or not 2b? That's it's 2b. Yeah, it is 2b. Okay, and then so now what we do is we equate the terms in x and the constant terms. So the only way that x plus 12 can equal this expression is if all the x terms turn out to be equal. So we're going to say that x equals ax plus bx. And then what else has to be true is that the non-x parts also have to be equal. So 12 has to equal 4a plus 2b. So 12 equals 4a plus 2b. All right? And then what we do here is essentially you're dividing out the x. You say 1 equals a plus b. You have to be careful doing that because do I know that the x is not 0? No. But what you're really saying is that if, regardless of what the x is, if 1 equals a plus b is true, then this is true. Because if x is not 0, you can multiply both sides by x and get this equation. If x is 0, you can multiply both sides by 0 and you still get this equation. So this is true regardless of whether the x is 0 or not. All right, so you don't have to think about that too much. You basically just divide the x out. Now what you got is an equation in 2 variables. And you can solve it either by substitution or elimination. This one's probably easiest to solve by substitution. So I'm going to say from this equation, b equals 1 minus a, and then I can substitute that into here and say that 12 equals 4a plus 2 times 1 minus a, and then we're back into pre-algebra world. 4a plus 2 minus 2a, 12 equals 2a plus 2, 10 equals 2a, a equals 5. Hey, a is over the x plus 2. 5 is over the x plus 2. I'll be darned. It works. All right. Now I need to know what the b is, though. So I have, I can go b equals 1 minus a. All right. So b equals 1 minus a, which is 1 minus 5, which is negative 4. So now I know that the b is negative 4. Hey, b is negative 4. That's why it was minus 4 instead of plus 4. All right. So this is the process by which you will take an integral of a rational function whose denominator, crucially, you can factor, and you split it up into two different fractions to add them together. We will do another example next.